Okay, with this video, I'm going to tell you what a combination is. Okay, a combination is basically a cousin of a permutation. All right, so a combination is a method of counting similar to a permutation in that a choice or an item cannot be chosen twice. So once we choose, for instance, we did an example on permutations where we chose either an A or a B. So uh, if we chose an A, then the only remaining option that we would have if we were going to make a second choice would be B. We couldn't choose A again. Okay, so that's similar to a combination. They have that in common. In common. However, with a combination, the order doesn't matter. So it's similar to what you already know, but it is a different method of counting. Okay, the order doesn't matter. So we distinguish it with a different letter, letter C. And so let's say we had n equal 4. Uh, Sort of a concrete example of this would be if we were going to choose from 4 different colors. Let's say we had 4 colors: red, blue, green, and orange. All right, so we could pick any of these 4 colors, and so n would be 4. But now we could say that R equals 2. We're only going to pick 2 colors. Maybe we're trying to come up with a new football team or baseball team or something, and we're only going to use a combination of 2 colors. So um, we could write this as red plus blue. We could write this as red plus green, red plus orange. And so there's all of these different possible combinations. However, the order doesn't matter. So if we chose blue and red, this would just be considered one combination. Okay, red plus blue and blue plus red are the same thing. Or likewise, if we chose green and then red, that is a second combination. Okay, it is different from the first. In this one, we chose a different color alongside red, but red then green and green then red, it's the same possibility, same outcome. And then, of course, red plus orange is the same as orange plus red. So we only count this once as a possible outcome. So this is a third combination. All right. And there's more combinations. There's combinations not using the color red. We could say blue-green or blue-orange or orange-green. So hopefully that gives you some idea of what a combination is. And if we had a probability calculator, then we could express the total number of outcomes by writing C n comma R or n c r. And in this specific case, we would write this as 4, and we could say choose 2. 4 choose 2. All right, and when we say choose, that sort of specifically refers to a combination. Likewise, we could write this as C 4 comma 2. Okay, so you should have some idea um, what we're doing here. And I'll throw up a little example that's in your workbook too. This is example 7 in your workbook. I don't always refer to them with the same number, but a lot of these examples I pulled from the workbook. So let's say a committee of 12 people. Okay, there's a total of 12 people in this committee. And they decide to select from their committee members a 3-person subcommittee. All right. What are all the different combinations that we could have a subcommittee? So let's say we had Robert, Dan, um, Elizabeth, and Shannon, and Amber. Okay, there'd be 12 of them. These were all of the, or some of the people on the subcommittee, or I'm sorry, some of the people on the committee. Now, if we wanted to pick a subcommittee, then we could put Dan, Elizabeth, and Shannon okay, this is committee, and so our subcommittee, one possibility could be Dan, Elizabeth, and Shannon. Now, if we were to pick Elizabeth, Dan, and Shannon, we just changed the order of the names, then you could see that this is the same set of people. It's the same combination. So these are not different outcomes. This is the same outcome. Okay. Now, um, calculating the total possible outcomes is super simple. I just really wanted you to understand how these different combinations are made. But to actually work this example and come up with the total number of ways that this committee can be filled is actually pretty simple. If we have a calculator, then all we need to do is input C parentheses 12 comma 3 or 12 choose 3. Okay. Now the formula for this is, like I said, combination is a cousin of a permutation. And so you can imagine, the combination formula to calculate this total number would involve a permutation. So we can actually calculate this. Let me use the numbers since I've got the numbers already put into the combination. We could compute this by computing a permutation with n equal 12 and r equal 3. except now we would divide that number in order to get the combination, not the permutation. We would divide the permutation with the same n and r by r factorial. In other words, the permutation with the same n and r divided by, in this case, r is 3, we would say 3 times 2 times 1. We would divide the permutation by 6. Okay, so that's how they are related. In order to get the number, then we could say all right, so we could say for the permutation, we would have 12 choices. But once we choose one person and we go to make a second choice, then we only have 11 people left to make a choice from. And if we make a third choice, then 2 of the people have been removed and we only have 10 people to choose from. So the 12 times 11 times 10 is going to take care of the permutation. All right. But now we want to account for the fact that the order of these 3 people that we chose doesn't matter. And so that's where this r factorial on the bottom steps in. And we've already computed r factorial at 6. So we just simply divide this by 6. And you could simplify this because the 6 would go into the 12. And the only operation on the top of this fraction is multiplication. So these would cancel out and they would give us a 2 times 11 times 10. And 2 times 11 is 22 times 10 would be 220. So with a committee of 12 total people, and we're going to form a subcommittee of 3 people, then there are 220 possibilities, and the order doesn't matter. So that is the basics of what a combination is and how you calculate it. Thanks for watching.